Hi everybody, welcome to review for Math 1324. Question 1. I've solved the problem. So pretty much we solve this equation. When we distribute the minus, make sure that goes to everything. So we have 7x minus 5x minus negative, that plus 1 equal to 2. Combine like terms, 7x minus 5x, 2x. And subtract 1 on both sides. We have 2x equal to 1 and divide by 2 on both sides. We have x equal to 1/2. Now we go to this one. For equation, when we add, subtract, multiply, divide, whatever we do on one side, we do on the other side. Same thing with this equation. To get rid of all the denominator, that will be easier. So we'll find the least common denominator, something that divide by all the denominators. So it will be 8 and 16. So that will be 16 because 16 can cancel with 16 and cancel with 8. So x over 16 by 5 over 8. And we multiply 16 to everything. So 16 and 16 cancel out, we have an x. Then minus 5 times 16, this cancel out. 16 and 8 cancel out, that 2. 2 times 5. That is 10. Sorry. And 8 and 16, that 2. I have x plus 6 times 2. So x minus 10 equal to 2x plus 12. And we'll move on the x on one side to solve for it. And move the 10 to the other side. Should I give us negative x on this side? And that cancel out 22. And divide by negative 1 on both sides. X equal to negative 22. So I actually have the timestamp, so to just read the description, the timestamp for each problem. So that is our solving equation. Now we have inequalities. Pretty much the same thing. The only thing different is if we have to multiply or divide by a negative number, then we have to flip the inequality. So first, I'll just multiply this out. We have negative 25x, negative 20, less than negative 30x, plus 25. Move all the x to the left hand side. That cancel out. And the 20. So that gives us 5x. Less than, that cancel out, 45. And then divide by 5. Since we divide by a positive number, inequality will stay the same. If we divide by negative number, this have to be reversed. So in that case we have x less than 9. This one we have to solve the inequality. We did. Now we have to graph it. it's less than 9 and does not have the equal sign, so it will be parentheses. So we have negative infinity to 9, not including the 9. On this, we're just going to get the x by itself. So in that case, move the 2. So that gives us negative 14 less than or equal to negative 2x less than or equal to negative 4. And with that, we divide by negative 2 to get x by itself. X will stay in the middle. Since we divide by negative number, this have to be reversed. And so we have x between 2 and 7. So we just have between 2 and 7, including so bracket 2 to 7. Right. We continue. I'll find the equation of the slope and intercept form will be in this form of the line with the slope equal to 3 and then go to the point. So we have y equal to mx plus b, and we have m equal to 3, and we go to the point. So in this case, x is 1, y is negative 2, and the slope is 3. So we have negative 2 equal to 3 plus b, and subtract 3 on both sides. So you have negative 5 equal to b. So now we have b and you have m is 3. So y equal to mx plus b. So y is equal to 3x minus 5. Of course, you don't have to write every step. But just write every step here so you can easily follow. Right. Next, I'll find the standard form of the equation of a line passing through the 2 points 2 to negative 6 and negative 9 and 6. The standard form of the equation is ax plus by equal to c. And the slope intercept form is y equal to max plus b. If we are given 2 points, let's say we have x1, y1, x2, and y2. The slope is y2 minus y1, x2 minus x1. y2 minus y1, x2 minus x1. So we have 12 over negative 11. So that is the slope. So having 2 points, we can find the slope given by this equation. Right, now we have slope. Next we have y equal to mx plus b. We can use one of these 2 points. I'm using x1, y1. So y1 is negative 6. The slope is 12 over negative 11 plus b. We don't know b. Actually, we do know x. X is 2. Plus b. Right. Now you have multiply everything by 11. That negative 66. 11 cancels. We have negative 24. Yeah, 2 times 12, 24, and 11 cancel. That's still negative, so that's why it's negative 24, and then plus 11b. So plus 24 on both sides. And we have negative 42 equal to 11b divided by 11. So b is negative 42 over 11. Now we have the equation y equal to mx plus b, y equal to 12 over, I put the negative in on the top like that, minus 42 over 11. Then I will multiply both sides by 11. 11y equal to negative 12x, because 11 cancel out here, minus 42, and then plus 12x on both sides. So we have 12x plus 11y equal to negative 42. Right. So linear equation, if we have 2 points, that is the slope. This is the slope and intercept form, and that is the standard form, and we have that. Right. Next, the cost of manufactured computer part is related to the quantity produced, so x. During that, when 100 parts are produced, the cost is 300. When 600 parts are produced, the cost is 4,800. So we'll make a little table here. X and cost. So when 100 parts are produced, the cost is 300. When 600 parts are produced, the cost is 4,800. So from that, we try to write the equations. C equal to mx plus b. So m, and the slope is y2 minus y1, x2 minus x1. So here we treat C as y. So y2 minus y1 over x2 minus x1. So 4,500 over 500. That is 9. Now we have the equation is C equal to mx plus b, and we use this point. I'll substitute that equation along with the slope is 9. Substitute that equation as well. So we have the cost is 300 equal to m times x of 100 plus b. M is equal to 9. So that 300 equal to 900 plus b, and subtract 900 on both sides. We have negative 600 equal to b. So we have e, we have b, we have m. So equation is c equal to mx plus b. So c equal to m is 9, x, b is 600. So the cost function is 9x minus 600. Right. Using a phone call to make long distance call is the flat rate of 85 cents plus 19 minutes starting with the first minute. Find the total cost of the phone call which lasts 8 minutes long. Right. So the cost. Flat fee of 85 cents, so regardless have to pay 85 cents. And then 19 cents per minute starting with the first minute. Right, so that pay that, and then you have 19 cents. Actually, starting with the first minute, that means when to make the first call, when you start the call, you have to pay 85 cents already, and then even though if you talk 1 second, you still have to pay the full minute. So that multiplied by 8 have 0.85. Sorry, 0.85 plus 0.19 times 8 and then 2.37. Right. Determine whether the relation represent a function. If it is a function, state the domain and range. So in that case, we just try to write out actually whether it's a function or not. We still can write the domain and range. Our domain is the first on the first component, and the range is on the second component. So we have the domain on the first component, and then the range on the second component, 5, 2, 1, 2 already, and then 10. Whether it's a function or not, we still can write the domain or range. Now to determine the function, we see each one of the domain corresponding to one of the range. Negative 2 to 5, that's good. Negative 1 to 2, that's good. 0 to 1, that's good. 1 to 2, that's good. 3 to 10. Yeah, you see each one in the domain, they only have one arrow. So that is a function. If you have one in the domain corresponding to in the range, that is not a function. So this one is a function. Find the domain of the function. For the domain of function, there are two things we need to watch out for. Is that the denominator is not equal to 0. and inside an even root have to be greater than or equal to 0. So those are the two things we have to watch out for. First here, this I do these two problems together. So the domain is x minus 2 have to be not equal to 0, denominator not equal to 0, and we solve for x easily, plus 2 on both sides. We have x equal to 2. Right. So if we want to, we can say it, can draw a number line. It's not equal to 2. Negative infinity to 2, or 2 to infinity. Right. This one we have under the square root, that have to be greater than or equal to 0. So my 3 on both sides. And divide by negative 1. Here we divide by negative number. We have to reverse inequality. That reverse. So x is less than negative 3. Wait a minute. Negative 2 divided by negative 1 is positive 1. Positive 3, sorry. Draw number line. And it's less than or equal to 3. So we have negative infinity to 3. Right. Times 10. Right, so this is a different quotient. The formula f of x plus h minus f of x, all that over h. So first f of x plus h. This is the function, so we write with the function equal to 3. Doesn't matter what we label in the parentheses. We replace all the x by the parentheses, and now we label, put whatever inside the parentheses. If we decide to put x plus h, we have to do that on both the x's, both the parentheses. So that gives us 3x plus 3h minus 7. Right. So 3x plus 3h minus 7. Right. F of x, that is the original function. So just 3x minus 7. But be careful that the minus here affect to everything after that. So I just change the, see what will be the better light here. So that gives us 3x plus 3h minus 7 minus 3x minus a negative. Be mindful with that. So that plus 7. Now in class we did say that for different quotient like this, if the term that have no h will stay, I mean we cancel out, this 3x doesn't have an h in it, that should cancel with something, and then the -7 cancel with 7, so we're left with 3h over h, and then we cancel an h, that gives us 3. So there are 2 steps: cancel everything without an h, and then cancel the h at the bottom. So those 2 steps you should see. The point at which a company cost equal its revenue is the break even. C represent the cost in dollars, X is the product, R represent the revenue, again X is unit. Find the number of units must be produced and sold to break even. So break even is where the cost equal to the revenue, so pretty much we just let them equal. So break even we have the cost equal to the revenue. Yeah, so break even I should write cost equal revenue. So we solve for that equation. Move on the action one side, sorry, and that number to the other side. Right, so that negative 3x equal to that will be sorry 6,000. Right. Negative 18,000 and divide by negative 3 on both sides. I'll end up with x equal to that divided by, so that's 6,000. So that is the number of units must be produced and sold to break even. Right. How can the graph be obtained from the graph of y equal to f of x? So in this case we have 2 things. The plus 1 here, we move the graph. The graph is moved 1 unit. To the left. And there's a minus here. There's the reflection. Reflection on the x-axis, or vertical reflection. Right, and order operation. Okay, order operation is do inside first. So this is the first step, and then second step, reflection on the x-axis, or reflection vertically. Yeah, like upside down. So in that case we say this first. So how can the graph be obtained from that? So we said shift 1 unit to the right, shift 1 unit left, and reflect vertically or on the x-axis. Right. So in this one, first we have the graph is the basic graph. Begin by graphing the standard x squared. So x squared is x squared. So we write the basic graph. And now we have the -3. Will be 3 units to the right, with minus x minus is to the right, and then plus 4 unit up. So 3 to the right. Here just a sketch. And then 4 unit up. 1, 2, 3, 4. So we have that 3 unit to the right and then 4 unit up. I'll begin by graphing the standard. The standard here is x squared. We have a few things here. -3, plus 2, sorry. 2 unit to the right, so that is the basic. 2 unit to the right. -1. 1 unit down. And then we have the minus. The minus reflect vertically. So the step is inside first and then outside. On the outside is multiply, divide before add or subtract. So we have to do in that order. First we move to the right and then flip it upside down. And then 1 unit down. Sorry. To the left. So that. And then flip it upside down. Sorry. This is to the left. So we're talking about this. And then 1 unit down. So the graph will start from this point. Right, so to the left, 2 unit first, flip it upside down, and then 1 unit down. Now we have this graph. So we move 2 units to the left, plus 2. So this is the given graph. So 2 units to the left. This is pretty similar to the previous one, plus 1. So 1 unit up and the minus reflect vertically. So follow that. And then inside first. And then outside there's multiply, divide, add or subtract. So the minus will be first. And then 1 unit up. So 2 units to the left. This point 2 units to the left. 2 units to the left. and then reflect this one up 4, it will be down 4, up 4, down 4. So the second step is reflect, and then 1 unit up, this 1 up, 1 up, 1 up. So that's what we have. So now we graph this. Y equal to 4, that's easy. Y equal to x minus 2. Make a table. When x equal to 0, y is negative 2. We don't want to choose the 2 points. That is too close. If you want to draw a line, it's much better to draw 2 points further apart. When connect them, it's easier to draw a line. So I might want to do something very big like this. 5 minus 2 is 3. So it is easier to draw the line when we have 2 points further apart. And then 5 equal to 3. However, this is only when x less than 1. So in that case, actually, I should choose something that is negative. Right? If it's negative 5, that would be negative 7. Okay. Better. And this go up to 1, but not including. And so we have to have not including. And after that, it is equal to 4 when it's greater than equal to 1. So that including. So the graph will have 2 parts, 1 and 2, including this point, but not including this point. Right, now we have parabola, the equation for a quadratic function. We will find the x-intercept, y-intercept, the vertex is at the maximum or minimum, and determine the range. So those things for that function. So the intercepts. So first the x-intercept. X-intercept may be more than 1. This is why we let y go to 0. So pretty much we let the equation negative x squared plus 4x minus 3 equal to 0. Now we just solve for x. Divide by negative 1 on both sides. So we have x squared minus 4x plus 3 equals 0. And we solve for this equation. So negative 4 plus or minus square root of b squared negative 4 squared minus 4 a c. Of course there are different ways to solve for quadratic equation, but this one is straightforward. Right, 1. So we have 4 plus or minus square root of 4 squared 16 minus 12 is 4, square root of 4 over 2. So 4 plus or minus 2 over 2. So 4 plus 2 over 2 is 3 4 minus 2 over 2. That 2 over 2 is 1. So we have 3 and 1. Next, that the x-intercept, the y-intercept. When x equal to 0, and to find y, we just substitute 0 in for x. So that's -3. So go back to answer the question. The x-intercept, x equal to 3, y equal to 0, or x equal to 1, y equal to 0. That is the x-intercept. The y-intercept, x equal to 0, y equal to -3. Now we go to the vertex. A vertex, the vertex where the x component is equal to -b over 2a, which is pretty much that formula without the square root. -b, remember we have to use the original function, not this. Actually, it will be the same. Oh, actually no, I have to use the original function. Negative b is 4 over 2a. So that is -4 over -2. Negative, that gonna be 2. And then y, we just substitute x values into the function. So -4, -3, so 8 minus 7 is 1. So the vertex is 2 and 1. Should be, to see 3 and 1, the vertex of the x will be right in the middle. Because the vertex is on the axis symmetry, and the x-intercept will be symmetric to it. So if we, because we can draw the sketch later. C, is that the maximum or the minimum? Right. So this has the coefficient of negative, so that we open down, and that will be the max. So we have graph open down. So vertex is maximum. And the next part is related directly to the maximum or the minimum. If the vertex is the maximum, that means the y values is the highest. So the range is going to be highest, going to be 1. So it have to be from 1. 1 is the maximum value. So we can write like that. Or if we want to write as the interval notation, be less than or equal to 1. Because we know this is the maximum, so the y values, this is going to be the maximum, everything will be less than that. Right. Now we talk about the graph, right? It go to the point 1 and 0, 3 and 0, and the vertex is 2 and 1. So graph like this. Because the vertex is on the axis symmetry 2, so the 2 will be split the x-intercept right in the middle of the x-intercepts. Anyway, so we have this from 19 and determine whether there's a maximum, minimum, and find that values. Right. Now we have this equation. The coefficient is negative. Just like the last problem, if it's negative, it open down. Of course, if it's positive, leading coefficient is it open up. So we write the graph open down. So with that, vertex is max. Now we just need to find the vertex. The formula for the vertex, x equal negative b over 2a. Negative b over 2a. So 3 negative sign, I have 18 over 2 is negative 9. Right? And then we still have to find the y values. Y equal to, when we substitute negative 9 into it, so negative 9 squared minus 18 times negative 9 minus 90. So negative 9 squared minus 18 times negative 9 minus 90. It is negative 9. So that also negative 9. So the vertex is negative 9, and the maximum, if we talk about the y values, it's going to be negative 9. So the maximum is the y values is negative 9. Because this open down, so the vertex is the max. Do this two problems together. Find the leading coefficient test to determine the end behavior of the polynomial function. So we look at the highest power term, will be this one. The coefficient is negative 4. It is negative, so we have the right end go down. And now we base on the degree. Degree is 4, which is even. Even meaning they have the same behaviors on both ends. Now if we have the same behaviors, the right end is down, so the left end is also down. So in this case we say the graph falls to the left and falls to the right. Now we have this one. Look for the highest power term. Will be that the coefficient is 1. Which is positive. If it's positive, the right end is up. Now the degree. Degree is 3, which is odd. So it's opposite behavior. the right end is up. It's opposite behavior, so the left end is down. So in this case we say it falls to the left and rises to the right. 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 This case we find for this we find the vertical asymptotes. Vertical asymptote is where we have the bottom equal to 0. We want that to be 0. If the bottom is equal to 0, divided by 0 is undefined. And vertical asymptote is where the graph has a break. So where the graph is discontinuous. So that's why we want the bottom equal to 0. So that's why we have a break on the graph. But we don't want the top to be 0. The top equal to 0. If both of them equal to 0, the graph will have a hole in it. So it's not that. So we have to have both. So for this case, we just let the bottom equal to 0. And we have x. Then x minus 1 equal to 0. And we just solve for it. Is x equal to 0 or x minus 1 equal to 0? So that gives us x equal to 1. Now we say at x equal to 0, at the top equal to 0 plus 1, and that is equal to 1, and that not equal to 0, which is what we want. And now at x equal to 1, the top will be equal to, put 1 in for x on the top, and that's not equal to 0, which is good. So in that case, this also good. So we have two vertical asymptotes, x equal to 0 and x equal to 1. Next, for this one, the same thing. Let the bottom equal to 0, and then let the top not equal to 0. That for the vertical asymptote. To solve for x. And then take square root on both sides. Remember, when you take square root on both sides, then plus or minus square root. So in that case, we have x plus minus plus square root 4, so plus or minus 2. Then we check. When x equal to 2, the top equal to 2 minus 2, that's 0. If it equal to 0, that's not what we want. And now we use negative 2. The top equal to, put negative 2 in for x on the top, and that is negative 4. Negative 4 is not equal to 0, and that's what we want. So in this case, there's only one vertical asymptote of x equal to negative 2. find the horizontal asymptote if any of the graph of rational function. Right. So this is the vertical horizontal asymptote. So in this case, it's easier. Just write three different scenarios, three different cases for the rational function where we have a polynomial on the top and bottom. So the horizontal asymptote, we have three cases based on the degree. If degree on top is bigger than degree at the bottom, so there be no horizontal asymptote. Case number 2, if degree on top is equal to degree at the bottom, will be y equal to the ratio of leading coefficient. And if degree on the top is less than degree at the bottom, then y equal to 0 is horizontal asymptote. Right. So we have three scenarios here, and now this first degree on top equal to degree at the bottom, both of them equal to 1. Equal to degree at the bottom. So when degree are equal, we take y equal to the ratio of leading coefficient. So just negative 4 over 5 is horizontal asymptote. 26, degree on top is 1, degree at the bottom is 3. So degree on top is bottom is bigger. Bigger than degree on the top. If bigger degree at the bottom, then we have y equal to 0 is horizontal asymptote. Right. Write the log. Next I will do these two together. Write the equation in its equivalent exponential form. So one of them is exponential form, the other one is logarithmic form. Exponential form is y equal to b to the x, and logarithmic form is log base. I want to keep the equal sign and then the base on the same side. So base b is log base b, and x and y swap, so that will be x and then y. So here we write the base here is 3 equal to a swap 2 and then x. The base here is 3 and then we swap 1 over 27 and swap negative 3 on the other side. Be just like that. Next, use the property logarithm to expand. So this is called expanding, this is called condensing. So I will write all of them just one formula. I mean three formula, but all together we'll write here. So if we have log of a product is the sum of the logs. log of the quotient is the difference of the log. And then if this is the case, we can print out the power as the coefficient. If we go from this side to this side, that is called expanding. If we go the other side, that we condense. Moreover, we can write similar thing here. If the terms are on the top or positive, it will stay on the top. So positive will be on the top, and if the term is at the bottom, it will carry the negative. Right. So I'm going to do all these 4 problems together. So this have the product of both of them on the top, so we be positive, both of them. And then we just bring the 4th in front. So at log base b of y plus 4 log base b of z. Right. Next, we have this. I can write the product here. So there are 2 terms on the top, 1 at the bottom. So the first 2 will carry the positive sign. And then the bottom will carry the negative sign. So we just that. That is called expanding. One big log break down to a bunch of little logs. Now we do the opposite direction, and this is called condensing. So in that case, if we want to condense, we go from this side to that side. Remember, the coefficient of them is just 1, so let's bring the 3 in front, and that gives us, this is log base x of 2 cubed plus log base x of 3. 2 cubed is 8, and when you add the 2 log, we combine into a product. That log base x of 24. Now, same thing here, we have to bring down the exponent. Bring the coefficient into as an exponent. Log b of m cubed minus log base b of n, and subtract, meaning dividing. Right, I stop the video here, and then I pick up the rest of the review on another video. Thank you for watching.